Hello, everybody. This is Sunday. It's October 24th, and here we are about to head into Module 9 of our online astronomy course. I hope you've had a good week, got some good rain this week. And before we start talking about Module 9, the important thing to say is that this coming week is your second exam. The exam opens up tomorrow, Monday, October 25th, and it lasts until next Sunday, which is October 31st, Halloween. So from tomorrow, Monday, until the following Sunday, you can take the exam. It's on the Canvas system. You'll find it right after the material on Module 8. And just remember, you can take it twice if you want to. If after you've done the first time, you can see what questions you missed, and you can look up those answers and then take it again. The exam is open book. You're also welcome to look at your homework quizzes while you're taking the exam. I don't think you're going to need a calculator. If you want to have a calculator handy, that's just fine, but that's all that's allowed. Nothing else is allowed. And as always, the best way to study for this is to look over the homework quizzes, make sure you understand everything on there. And I always do ask a couple questions on the videos, just to make sure you're watching something very, very simple. And in fact, I've just sent out an email to all of you this morning with all of this information in it. So please, sometime this coming week, take that second exam. And also this coming week, we're moving into Module 9, which means we're moving into the third part of the course, the part of the course that is on the sun and other stars. And this module, we'll be learning about our sun, the nearest star to us. It is unbelievably huge. As you can probably tell by this background that's in back of me right now, this shows the edge of our sun. And if I move just a little bit to the side, you can see that there's a giant flare that's bursting out of the sides of the sun. And right here is our Earth, just for a size comparison. The sun is huge. If you could hollow out the sun and drop in Earths one at a time, drop in planet Earths, you could fit 1 million Earths inside the sun. It's a huge ball. It's mostly hydrogen. There's some helium there, but mostly it's hydrogen and helium gas. There's no solidity to the sun at all. It's entirely gaseous. And although the surface of the sun in this photo looks like it's burning, it's really not. It's just glowing red hot. And if you've ever seen a piece of metal, had it heated up so it becomes red hot, and it's giving off black body radiation that we talked about several modules ago, that's what the surface of the sun is doing. It's giving off black body radiation. It is very hot. It's about 5,770 something degrees Kelvin. That translates into about 10,000 degrees Fahrenheit just on its surface. And it is much hotter in the center, which is where the sun's energy is generated. You know, the sun liberates a huge amount of energy every second. If you could capture all of the sun's energy, just 1 second's worth, that would supply Earth's energy needs for 800,000 years. Just a truly incredible amount of energy. And what can supply that energy? I mean, again, I already said the sun is not burning, and it's not. It's not a chemical fire like the burning of charcoal or wood or something like that. It's a nuclear fire. And what happens is that in the center of the sun, all of the atoms, it's so hot, all of the atoms have lost their electrons. So what you have in the sun are bare nuclei, the central parts of atoms. And those atoms are moving very fast. Those nuclei, I should say, are moving very fast. And in the center of the sun, what can happen is that 4 hydrogen nuclei, 4 protons, can come together to form a single helium nucleus. Now, it turns out that for every, let's say, 1,000 kilograms of hydrogen that goes into that nuclear reaction, only 997 kilograms of helium come out. I'm sorry, 993, excuse me. 993 kilograms of helium come out. So 1,000 hydrogens come in, 993 kilograms of helium come out. There's 7 kilograms missing. Where did that go? Had to have gone somewhere. And the answer to that is Einstein's famous equation, E = mc squared. That mass, that 7 kilograms of mass, was converted into energy, completely converted into energy. And the conversion factor, mc squared, so that 7 kilograms of mass is multiplied by the speed of light squared. And the speed of light is a huge number, and squared, it's even more huge. And so a little bit of mass can liberate a lot of energy. And in fact, each second, about 4 million tons of the sun's mass is being converted into energy. And that's what produces the sun's light, its heat. And so when you go outside on a nice warm day and you feel the sunlight coming in and hitting your face, you are experiencing the energy that was created in the center of the sun by the nuclear fusion of 4 hydrogen nuclei into a single helium nucleus. It's a great study. You'll also learn about the sun's outer layers, its atmosphere. And what you're looking at in this image right here is an image of the outer part of the sun's atmosphere. So you'll learn about the flares that come up. You'll learn about all of the energetically active things that happen on the surface of the sun. And you'll also learn about the little ghost particles called neutrinos that are created in the center of the sun and that fly to Earth in a very short amount of time, nearly the speed of light, and allow us to look into the central core of the sun and verify our understanding of the nuclear reactions that are taking place there. So it's just amazing stuff all about our sun, and you'll be learning all about that in Module 9. I want to take a look at the sky right now. So let's do that. I'm going to share the screen and take a look at Stellarium. So let's take a look at that. And here we go. This is midnight on the 27th. So this is Wednesday midnight. Or maybe it's, gosh, I don't know. I guess this is actually the 28th on midnight, 27th or 28th. But what we have here is, yeah, go out late Wednesday night. When midnight rolls around, this is what you'll see. And it shows the moon just rising in the east. And it's right in the middle of the constellation Gemini. Gemini is not one of the constellations you have to know, but here's what it looks like. It looks like 2 stick figures holding hands there, Gemini, the twins, and the moon is right in the middle of Gemini at the moment. But just rising in the east is my favorite constellation of the winter sky. This is the constellation of Orion. Here is Betelgeuse, the red giant star. And this is Rigel, which is a bluish white giant star. And right down here is the Orion Nebula. Here are the 3 stars in Orion's belt. Orion is supposed to be a mighty hunter, as you can see here. Here's a hunter, his club is raised. There is Betelgeuse in the giant's armpit. In fact, literally translated from the Arabic, Betelgeuse means armpit of the giant. Here's Rigel down there, the giant's foot. and the giant has his club raised. So right down below these three stars, which are Orion's belt, right down here is the Orion Nebula. And we'll find out that is a place where today, right now, new stars and new stellar systems, planetary systems are being formed. So some of my favorite constellations in the sky right now, if you look straight up from Orion, you'll see the Seven Sisters. The Seven Sisters, also known as the Pleiades. And you know, other cultures have also seen the Seven Sisters in the sky, and 7 is a good test of eyesight, that you can see 7 stars there if your eyesight is good. Maybe see 8. There's actually a lot more than 8, but 7 are fairly easily visible. And what's cool is that if we take a look at not what we see in the sky, but try to see it through the eyes of another culture, because all of these constellations are just made up. And let's take a look at Native American, the Lakota people. What did they see in the sky? Well, let's take a look here. Here are the constellations. But if we take a look at constellation lines, they look quite different. For instance, here is a constellation called the Bear's Lodge, translated into English. Here is, I don't know if that's Nape or Nape, it means hand. This is a buffalo embryo, excuse me, buffalo embryo. And up here is, see, looks like Wisinkala Sakoan. I'm unfortunately not pronouncing that correctly, but it's the 7 girls. So again, the Pleiades, you can count 7 of them. And let's see the figures. Oh my gosh, very colorful constellations here in this Lakota cosmology. And if I just move around to other parts of the sky, we see a turtle, we see an elk, we see dried red willow. So it's important to realize that although we are just looking at the Western constellations, that other peoples have looked up into the sky and have created their own constellations. But still, looking at the Pleiades, there's 7 of them out there, regardless of who's looking up. So, take a look out tonight, if you or out sometime this week when it clears up. Right now, it's pretty cloudy out. But take a look later this week, late at night. Maybe you'll see Orion just barely creeping up above the horizon in the east. Well, I hope you enjoy learning about the sun. Next week, we'll move on, not next week, but the week after that, we'll move on to other stars, learn about those, and be sure and take your exam next week. Good luck on that. If you have any questions about anything, if there's anything you want to know before you take the exam, you're welcome to contact me. You can use the course email, you can post in discussions. I'll be happy to set up a Zoom for you. And anyway, good luck taking that exam. Next week, week after next, on to the stars. And until then, I will see you later. So, bye-bye.